Welcome back. Last time, we learned the names of the pharaohs, how they were written, and I said we would look at Tutankhamun's names. Let's just look at Tutankhamun's nomen and the prenomen, the two names in cartouches. We'll see them again at the end of this course, but let's look at them now also. Repetition is useful in learning any language. The prenomen, the one preceded by the sedge plant and the bee, king of Upper and Lower Egypt, is the difficult one to translate. We can quickly recognize the sun hieroglyph for Re. So the name has Re in it. Next, we recognize the beetle or scarab, which means to exist and was pronounced cheper. But it has three strokes for plural after it. That would make it cheperu. That's the hard part. Why plural? Emphasis? Then the semicircle biliteral, neb, is not a problem. It means all, but also Lord. Here, Lord is probably the best. So neb keperu re is often translated as the lordly manifestation of Re. This name, of course, is not the Tutankhamun name. That's the next one, the nomen, the one preceded by Sa-Re, the son of Re. Here we see, right up front, where it should be, the name of the god, Amun, written as Imen. Next, we can see the tut part, as a word that means image. And then we have the Ankh. So Tutankhamun is made up of three distinct words and means the living image of Amun. So don't be confused when you see Neb Keperu Re and hear, oh, that's Tutankhamun. It is, just not the name with Tut in it. It's kind of like when some of my friends call me Briar, and then some call me Bob. I'm still the same person, just two different names. The order of the hieroglyphs in Neb Keperu Re is interesting, because there was a god, Khepri, who was shown as a man with a beetle head. Thus, we may have double honorific placement here, both the Re and the scarab coming before the Neb sign. The gold mask of Tutankhamun is probably the most famous object from the ancient world. And now that we know something about the names of the kings, I want you to look at it closely. Which of the 5 names do you think is most closely associated with it? Yep, you've got it. The 2 ladies' name. Right on the forehead are the cobra and the vulture goddesses, Ujat and Nechbet, the 2 ladies themselves, and they are protecting the deceased king. Enough on names of the kings. It's time for something different. Remember way back when we had a lecture about Egypt and why it had to have writing? We talked about keeping track of taxes, the army, and when the Nile would rise. Well, all of this involved counting. And today, we will look at hieroglyphs for numbers and Egyptian mathematics. But first, let's check the homework. We begin with a hieroglyph to English sentence to translate. Well, it looks like our first word is a predicate adjective. It's the word for bad, pronounced bin, with a little bird determinative, right? We quickly spot the wowie bird, so it's how bad. What's our next word? Yes, it's itru, river. Good. The next word is free or empty, shu. Again, the word ends with the little bird determining unfortunate things. Next, the owl probably means of. And our final word is water. So we have the words. We just need the sense of the sentence. Well, we start with our how bad. And if we supply the word when, then it all falls into place. How bad it is when the river is empty of water. Good. Okay, it's on to the second sentence. As usual, we start with the verb, to say or tell. That's followed by the suffix pronoun for you, and that's followed by a dependent pronoun, the folded cloth and loaf, which is it. So, you tell it. That would have been pronounced something like, Dejet que set. Then, as we might expect, there's a to for people, the water sign. To whom do you tell it? This is one of our new vocabulary words, iti, the sovereign. Next, we have another of our newer vocabulary words, ich, which means then. So you tell it to the sovereign, then something happens. What happens? We have our verb, dejet, again, to tell. This time, the sovereign tells it to whom? The maidservant likewise. The word likewise is just a form of our word me, which means like or as. Sounds like we have a blabbermouth sovereign. You tell it to the sovereign, then he tells it to the maidservant likewise. One last review sentence. Our first word is cha, to appear. Next, we have the sun. So it's the sun appearing. Where? Well, we have the owl, so that's in. And we see from our next word that it's the horizon. It's an ideogram, the sun rising or setting in a notch in a mountain. So the sun appears in the horizon. Now we have another verb, weben, to shine. That's followed by the suffix pronoun viper, he or it. So it shines. Then comes in the sky. Now we have another verb, actually a predicate adjective, nefer, to be happy. It could also be good or beautiful, but I picked happy because I see what's coming next. We have the heart ideogram above the neb semicircle, which means all or every. So it's every heart is happy. Next, another verb, ma'ah, to see, followed by the they suffix pronoun. So it's they see. But wait, there's more. We have a pronoun, su, which is it or him. To be consistent, let's say it. So our sentence is something like, when the sun appears in the horizon, it shines in the sky. Every heart is happy when they see it. Good. You did well with the homework. Now it's time for a grammar lesson. Let's learn our numbers. There's a common misconception that the Egyptians were advanced in mathematics. I think this idea originates because the pyramids are so precisely laid out. There is indeed remarkable accuracy in the construction of the pyramids. But this is great craftsmanship, not mathematical skill. The truth is that they were not particularly good at math. They couldn't do complicated calculations, especially with fractions, and they often had to approximate rather than get a precise answer to a problem. Still, I think you will find their mathematical system interesting. Let's start with the simplest mathematics, counting. Much of the impetus to develop a mathematical system came from the fact that they were a great civilization with a large bureaucracy. They had surpluses, soldiers, huge herds of cattle, and they all had to be counted. Also, each year, when the Nile overflowed its banks and inundated the land, it washed away boundaries. So the land had to be resurveyed. Again, a practical reason to develop mathematics. Let's look at the basics. The hieroglyphs for the numbers, from 1 to 9, were simple strokes. So if you wanted to say one boat, you wrote the word for boat, followed by a stroke. Note that the stroke is larger than the strokes for ideograms. The numbers follow the noun. So if you wanted to say 8 boats, you wrote boat 8. The strokes are arranged in 2 groups of 4, not strung out 8 in a row. Just as with other hieroglyphs, they wanted the arrangement to be visually pleasing. The strokes work for 1 to 9. But then we get to the tens. We have a new hieroglyph, the hoop. So 20 boats would be, if we wanted 24 boats, it would look like this. You can see that the larger unit, in this case the tens, comes first. Let's keep counting. For the hundredths, we use a coil of rope. So let's translate a phrase. First, the noun is day, haru. So how many days? Well, we have 3 hundredths, 6 tens, and 5 ones. 365 days. That's how long the Egyptian calendar was. We get our calendar from them. Well, we'll talk about that later in the course. For 1,000, we use the lotus flower, which is also a biliteral pronounced cha. Remember when we looked at the Narmer palette? There was one scene with a captive being held by a ring in his nose. In that scene are 6 papyrus plants, and I suggested they might be early hieroglyphs for 1,000, indicating that there were 6,000 prisoners. Well, the Narmer palette is a very early document, and my bet is that the papyrus plant indicated thousands then, but 1,000 years later, the lotus was used. So for our time period, we use the lotus for 1,000. So what's this? We just count the numbers. It's 1,224 cities. Counting is easy. Let's keep going. For 10,000, we use a finger hieroglyph. So if we wanted to say 20,441 scribes, we would write. We don't know how most of the numbers were vocalized, so we'll have to rely on our visual memory to remember them. Moving up, we need the hieroglyph for 100,000. That's a tadpole. I suspect the Egyptians chose the tadpole for 100,000 because tadpoles were so numerous. Our last number is 1,000,000. That's as high as the hieroglyphs go. It's the god Heh with his arms up. It's almost like he's saying, wow. On his head is a palm frond, the symbol for year. He also gives millions of years to the pharaoh's continued existence. So, if we wanted to write 1,782,588 donkeys, we would start with donkey. And remember, it's onomatopoetic. It sounds like a donkey. E'ah. Then we add the million hieroglyph. Next, we need 7 tadpoles for 700,000. Sometimes the tadpoles might be stacked, 4 on top, 3 on the bottom. There's no hard and fast rule. Now we need 82,000. We begin with 8 tens of thousands. The finger is the 10 of thousands hieroglyph. So we add 8 fingers. We need 2 lotus plants for the 2,000 part. Now, coming near the end, we need 5 hundreds, or coils. Good. Next, 8 hoops for the tens. And last, 8 strokes. That's 1,782,588 donkeys. The counting numbers are called cardinals. When it comes to the ordinal numbers, words like first, second, third, and so on, The Egyptians had some ordinals, but they often just used the cardinals, and we can do that also. Fractions are another story. Fractions are where the Egyptians really disappoint me. They were terrible at writing them. They couldn't operate with a numerator other than 1. So a fraction like 63/64 would be treated as 1/2 plus 1/47 plus 1/8 plus 1/16 plus 1/32. Not easy to work with. Usually, they use the mouth hieroglyph, the R, to indicate a fraction. 1/5 would be written by the mouth sign with 5 strokes beneath it. 1/276 would be written like this. But to write 4/7, they would have to factor it out to 1/2 plus 1/14. The Rhine mathematical papyrus, once owned by the Scottish Egyptologist Alexander Henry Rhind, presents all kinds of problems and their solutions. One example shows how cumbersome it was to work with fractions of only 1 as a numerator. 2/61 had to be written like this. That's 1/40 plus 1/244 plus 1/488 plus 1/610. Almost impossible to work with. To be fair to the Egyptians, I should point out that the Greeks used pretty much the same system, even though they were far more skilled at geometry. The Egyptians had signs for a few of their fractions. The most important is 1/2, which was often expressed by this hieroglyph. It may be the side of a statue base and meant not only 1/2, but also side. In a sense, the side of something is only half of it. The special hieroglyph for 1/4 was a cross or sideways plus. Let's look at some examples of numbers from the Rhind mathematical papyrus. I'll pick some difficult ones to really test you. Try this one. Let's look at it together. The first tricky part is 5 strokes at the beginning. There's no mouth sign before them, so it's not a fraction. It's just the number 5. So the number will be 5 plus some fraction. Okay, let's continue. Next is the special fraction for 1/2. It's followed by the fraction 1/7, and that's followed by the fraction for 1/14. See the hoop and the 4 strokes? So that means we have a number 5 plus 1/2 plus 1/7 plus 1/14. Remember, there's no and or plus sign in Middle Egyptian. Our number is equal to 5 5/7. Now for the next one, I'll give you a clue. The number is half of the one we just translated. Well, we have some experience now. We know that the first 2 strokes aren't a fraction. They're the number 2. Next is our special sign for 1/2. Then comes the special sign for 1/4. So far, we have 2 plus 1/2 plus 1/4. Next, we have 1/14, because we have the mouth sign before the hoop and 4 strokes. Finally, we have 1/28, all of which adds up to 2 24/28, which simplifies to 2 6/7, which, as promised, is half of 5 5/7. But our Egyptian mathematicians couldn't write it that way. They had to use only numerators of 1. We've been looking at pure numbers, numbers that can be used to count or order anything from boats to people. But there were also special units of measurement used for various commodities. Just as we have pints, quarts, and gallons for liquids, and inches, feet, and yards for linear measurements, the Egyptians also had special units. My favorite is the measurement for volumes of grain. You'll see why. Just wait a minute. The basic unit was a hecat, which is written in several ways. This is the most common way. The crook is pronounced heka. We have a hill-q phonetic complement, the feminine T, and then a determinative showing grain pouring out of a receptacle. A simplified way of writing hekat was just a grain barrel, with or without the stroke. Now for the really cool part. There are special signs for fractions of a hekat, and they're based on mythology. Let me explain. Remember the myth of Isis and Osiris, and how Osiris is killed by his evil brother Set? Well, Osiris's son, Horus, avenges the murder of his father by battling his evil uncle Set. In the battle, Set is defeated. Note, defeated, not killed. I think this is an existential statement, that evil will always be with us. In any event, Set is defeated. But in the fight, Horus's eye is taken out. As you know, Horus is often shown as a falcon, and falcons have a unique marking around the eye. Well, according to the myth, the pieces of Horus's eye were gathered and reassembled, but one small piece was missing. Thoth, the ibis-headed god of writing, magically recreated the missing piece and made the eye whole. Because the eye was made complete, it became a symbol of health. Often people wore Eye of Horus amulets for protection, and there are some Eye of Horus amulets that are found in tombs all the time. They're small, and I think you can see the details of the falcon's eye. But let me show you the parts in detail. The eye was such a popular image of health that it has even entered into our culture. Do you know what symbol we have connected with medicine that comes from the Eye of Horus? It's the pharmacist's RX. It's 3 elements of the eye. By the Middle Ages, the meaning of the eye had been lost, so the image was misinterpreted as Latin letters. In ancient Egypt, the different parts of the eye became fractions used to indicate parts of a hecat, the grain measure. The circular pupil is 1/4. The long curl on the bottom right is a 32nd. The triangular area to the left of the pupil, 1/2. And so on. Recently, one scholar suggested that this mythological interpretation is based on an incorrect interpretation of ancient handwriting. He might just be right, but it's still a cool story. Let's look at how the scribes tallied grain. When they were talking about whole units, not fractions, they would have the grain measure hieroglyph followed by circles rather than strokes to indicate the number of hecats. The dots are because grain comes in small pieces, grains, and the circles determine things that come in chunks, large or small. If you wanted to say 8 1/4 hecats, you would say 8 hecats, and then follow it with the pupil hieroglyph, which is 1/4. Grain was central to the Egyptian economy, and grain taxes were levied not by how much you grew, but by how high the Nile rose. The idea was that the tax collectors didn't want to have to search for hidden grain that the farmers didn't want taxed. So they measured how high the Nile rose that year, calculated how much grain you should be able to grow, and taxed you on that. If you should be able to produce 100 hecats of grain, let's say the government's cut was 50%, or 50 hecats. At harvest time, you had to give the tax collector his 50 hecats, and you kept 50 for yourself. If you were lazy, didn't dig enough irrigation channels, and only produced 70 hecats, well, you still had to give the taxman his 50 hecats, and you'd only have 20 for yourself. On the other hand, if you worked extremely hard and produced 120 hecats, you gave the taxman his 50, and you got to keep 70 for yourself. It was a system that encouraged industry and production. So at harvest time, up and down the Nile, scribes and tax collectors were using the measurements we have just been talking about to record how much grain Pharaoh was going to get that year. Grain wasn't the only thing Egyptians had to measure. The ancient Egyptians were great builders, so they naturally had to measure length, the length of a pyramid, the length of a temple, the length of a ramp. The basic unit of length was the cubit. That was originally the length between the king's elbow and his middle fingertip. It was standardized, and that was equal to about 20.5 inches. So most monuments were planned in cubits. The word for cubit was pronounced something like neh, and was written like this. The hieroglyph on top is a whip, and is the meh biliteral. The arm underneath is a determinative. The cubit is the distance of the arm to the fingers, so that makes sense. Sometimes the word for cubit is just written as an ideogram. Often it's written without the stroke, even though it's an ideogram. A cubit was divided into 7 palms, and the word for palm was seshespep, which was written like this. The palm would have been just under 3 inches. The hieroglyph is a fence and is a triliteral for she-se-p. So the square is a phonetic complement, the P just clarifying the pronunciation of the triliteral. We're not sure where the crescent moon comes in there. It must be a determinative, perhaps indicating part, since the crescent is part of a full moon and the palm is part of a cubit. The moon determinative is important because sometimes it serves as the abbreviation for palm. Now, palms are divided into 4 fingers, or digits. The hieroglyph for finger is the ideogram finger. It's the same hieroglyph as for 10,000, but you won't get confused because of the context. When we're talking about linear measurements with cubits and palms, you'll just assume we're talking about fingers and not 10,000 of something. For longer measurements, there was a unit of 100 cubits called a rod, which was pronounced chet. Let's translate a measure. Well, the first word we recognize is for cubit, the whip in the arm. It's followed by 4 strokes, so that's 4 cubits. Next is the crescent moon for palm, so that's 4 palms. Last, we have 2 digits, so the measure is 4 cubits, 4 palms, and 2 fingers. From what we've seen today of ancient Egyptian mathematics, I think you will agree that there is little to suggest the brilliance that is often claimed. They could certainly count just fine, had various units of measurement for different commodities, could survey the base of a pyramid with great accuracy, but not much beyond that. Their fractions were clumsy. Just imagine multiplying and dividing within their system. Still, it's important that we can translate their sentences with numbers. So, let me give you a few examples to translate for homework. Try 11,287 scribes. Then do 87 donkeys. How about 57.5 hecats? And then 4.25 hecats. Next, let's try length. A boat, 52 cubits, 4 palms, and 3 digits long. A house, 1 rod, 4 cubits, and 3 palms long. That's your homework. But I don't want to leave you with a totally negative feeling about how the ancient Egyptians used numbers. So let me say that next time, I will show you an Egyptian counting system that changed the world forever. I'll see you then.